Hey fellow coders, so are you struggling to solve this Leetcode problem called maximum twin sum of linked list? If so, you are in luck. In this video, I'll show you how to solve this problem in few easy steps. So without wasting any time, let's get started. Now let's try to solve this. So there are actually two ways to solve this problem, but we'll be discussing only the optimized way. So actually the first way to solve this problem would have time complexity of big O of n, and it will have also have a space complexity of big O of n. Okay, so this is using stack. We won't be discussing this approach here, but you can get this approach online now. But let's try to solve it using the optimized approach, and that is what the interviewer will be expecting you. So this would take what we will discuss as big O of n time complexity, and but it will have space complexity as constant. So this is what the interviewer will be looking for, and we'll be solving it using this approach. Okay, so now let's try to see it. So let's say this is the array given to us, and what we need is we need to return the maximum sum, that is we need to return the sum of these two, uh, and then we have to check the sum of these two, and then we have to check the sum of these two. Out of these three sum pair, we have to return the maximum one. So how we can actually do is we can if you see, if this was not a linked list and this would have been an array, what we could have easily done is we could have taken a one pointer here that is pointing to 1, and we could have taken another pointer here that is pointing to 6, and then we could have added this. Once we have added it, we could have stored it into some variable, and then increase this pointer here and then decrease this pointer, and then we could have done the same thing for this 2, and we could have done the same thing for 5. But since it's a linked list and we can't actually go back, so going from 6 to 5 is not possible because 6 don't have the any information about 5. So this approach won't work in the linked list. But if this would have been an array, this would be a pretty straightforward solution. Okay, so how we can actually solve this is, if you see this one, we need to add it to this 6. Okay, so let's say if we somehow reverse the linked list, a half linked list, that is, if we somehow reverse this linked list, we could actually solve it very easily. So let's say this was 4, 5, and 6. If we reverse this linked list would look something like a 6, 5, and 4. We have just reversed it, and this would have been something like a reverse linked list. Now what we could actually do is we can take one pointer that is pointing to 1, and we could take another pointer that is pointing to 6, and we could add those sum. Once we get this sum, we could actually get the uh, we could check the sum maximum what we need. So once we have this sum, we can store it in a max variable, and then we can check for these two pair, and another pair we could check for these two pair. Since we can move towards the right of this linked list, we can actually do this, and this is very possible. Okay, so this is how we'll be solving this problem. We will actually reverse the second part of a linked list, and then we can simply iterate over the first part, take the two pointer, that is one that is pointing to first part, and another pointer that is pointing to the second part, and we can solve this problem. So now let's try to see. There are actually two things which we need to see. Is the first question you may have is how to find the middle element from where we need to reverse. So first thing what we'll be seeing is how to find the middle element. So once we have the middle element, we have to actually reverse the second part. So second part will be reverse the second half of the linked list. Once we have the middle element, we have to reverse the second half of the linked list. Once we have reversed the second half of the linked list, we could iterate, use two pointer approach. That is one pointer that is pointing to the first part of the linked list, another pointer that is pointing to the second part of this linked list, and calculate the sum. So we could use something like a two pointer approach and get the sum pair. We can get the sum pair, and once we get the sum pair, we can dynamically store the max here, and we can simply return the max value once we got. So this algorithm uses these three simple steps, and now let's see one by one. Okay, so now let's try to find the middle element. We'll find the middle element using something called as rabbit tortoise steps. So there, let's say there are two person, Ram and Syam. So Ram is actually twice as fast as Syam. So what? Let's say if Ram takes one step, will Syam can take two steps. That is one and two. Now again, if Ram takes one step, Syam, as I said, Syam is twice as fast, so Syam can take two step, one and two. Again, if you see, if Ram takes one step, Syam can take two step. That is one and two. Now, if you see, we have reached the end of the linked list, and what this and now if Ram is actually pointing to the middle element, so we just have to say that like this next element will now be the middle element. So since and this guy was moving twice as fast as this guy, and this, if this has reached the end, means this will be at the halfway of the linked list, and we can simply say that its next element is actually the start of the element what we are looking for. Okay, so this is how we will find the middle element. Reverse the linked list. So actually reversing a linked list, we just have to reverse the connection and a linked list will automatically be removed. So let's say one is connected to 2 and 2 is connected to 3, and this is the second part of the linked list which we actually need to reverse. So what we can simply do is we can like right now 1 is pointing to 2, we can point 2 to 1, and we can point 3 to 2, and we can point this 1 to null. So by doing this, our linked list has automatically been removed, and we should actually remove these connections. And once we do all these things, if you see, our linked list has been removed. So let's try to see how we can achieve this via code. So let's say this was my linked list earlier, what we needed, and this is the future of state of the linked list. So where my pointer will actually point to, let me redraw it somewhere. So this is the linked list which we actually need to reverse, and we have to achieve this state once we have reversed. So I'll have something called as my previous pointer. So let's say this is previous right now, and this is pointing to null, that is nothing. And I'll have something called as a current pointer that will point to the start of the linked list from where we need to reverse. Okay, so using these two pointers, we can actually reverse the linked list. So right now, if you see, my current is pointing to this 2, but what we need in the future state, if you see, my current dot next should actually point to a null value. Okay, so what we can simply write is we can say something like as point my current dot next to previous. So what this will do, this will make a connection which will look something like this, and this connection would be removed. Okay, so if you see, there is one problem, because if we remove this connection, we would have lost the track of 2. So before actually writing this line, what we could actually do is we can store this 2 somewhere. So let's say we can take something like as current node. This current node will node next, we can say something like this, and we could actually store our current dot next to this node. So this will actually store this to information so that it will not be lost. Okay, so now we have stored this information, and we have pointed a current dot next to previous. So we are done with this thing. Now for the next operation, what we need to do is we actually have to move this current uh, to 2. Okay, now we have reversed the one array. Now we have to move this current to 2, and where my previous should move to, my previous should move to 1. So we'll simply write this two things. We can say something like as move my where what is my previous. So my previous will be nothing but my last current value. If you saw, current was actually pointing to this place, And what would be my current? My current is 2, which we have already stored here. So I'll simply write it something like as current is equal to current node next. So if writing these 4 lines will actually do the trick. Okay, so let's try to run it for the second iteration. For the second iteration, my previous is this, my current is this. So what this line will do, this current next node next, let's call it CNN. Okay, so my CNN will point something to this point, because this I have written current dot next is this one. So my CNN will point something to this. Now current dot next equal to previous. So what this line will do, this line will actually make a connection that will look something like this. That is current dot next point this to my previous. Once I actually write this, it will automatically break this connection, because now my 2 is pointing to 1. Okay, and what is the second line that I have written? That third line, that is previous equal to current. So now my previous will pointing to this node, that is right now current. And let me write it here. And current equal to current node next. So now my current will actually point to, sorry, my current will actually point to this value, that is here. And previous, as we have already written, this is pointing to this. So if you see this, by doing this, now let's try to run it once more. Let me remove this CNN right now. Okay, so this is how my node will look like after we have run it 2 times. Now let's try to run it once more. Now where my CNN will point to, my CNN will now actually point to current dot next, that is null. So this is where my CNN will point to. Now current dot next equal to previous. What this line will do, this will make this connection that current dot next equal to previous. And now where my current will point to, current will actually point to CNN, and where my previous will point to, my previous will point to this 3. Now we can end this thing, and once we can end it, and that's all. We have ended this thing, and if you see, this is the resultant linked list what we have got, which is actually the reversed linked list. So this is what we wanted, and this is what we got. So one thing we can also add here is we can add a while loop, because till where we need to run till the point current become null. So if my current is not null, run it, and at the time when it become null, you need to break it. So writing this while loop will actually reverse my linked list, not the complete linked list. Will start my current to the second half, so it will reverse the second half of the linked list. So hope you are clear in these two parts. Now we'll jump into the coding screen and try to write what we have discussed. Let's try to code this out. So I'll be using Java to write the code. You can use any language of your choice, but the basic algorithm will remain same. So what we discussed, to solve this problem, we'll need 3 steps. First thing is we need to find the middle element. Find the middle element. So how we can find the middle element? As we discussed, we need to use something called a slow pointer and fast pointer approach. So we can have a slow pointer, and right now this will pointing to the head of my linked list, and we can have a fast pointer. This is right now also pointing to the head of the linked list. So till where we need to run, till my fast has become null. Okay, and my fast dot next has also become next. This will ensure null pointer exception. So writing these thing, we can once we write this, we can move slow one step at a time. We can move slow is equal to slow dot next, but we can move fast, that is 2 step at a time. That is fast dot next dot next. So fast is actually twice as fast as slow. So once we have run this, actually my slow pointer will be pointing to the dot middle. That is, if for even length, let's say if there are 6 element, my slow pointer will pointing to the fourth element. That is 4, 5 and 6 is what we need to reverse. So we right now we know my slow pointer is pointing to the uh, middle plus one element. Okay, so now what we need to do is we need to reverse the second half. So where my slow pointer is pointing to, slow pointer is pointing to the second half element. So we just have to check, reverse the linked list to do the, we can say something like if my slow is not equal to null, we have to run this. Okay, so but before doing it, we let's take something called as previous, and what we discuss as CNN, what we were calling on the code, we'll call here it as next node, and we'll call something called as previous, which is right now null. Okay, so now what we have to do is slow is not equal to null. So what we can write is, let's try to store our next node first so that we don't lose it. So we can simply write as slow is one, that we'll are treating as this as current. And once we have stored this, we could write something like that, slow dot next equal to previous. This will make the reverse connection. Now we just have to update a previous is will be slow, and we have to update as current, that is slow, to next node what we have stored. So writing these lines will actually reverse the linked list. So now we'll do a third part, which is the easy one, but we haven't discussed this while we were doing it. So here we'll have again two pointer approach. Now this will actually get us the result. So let me write it down as two pointer to get the maximum sum. So if you see, my previous is pointing where my previous will point to, my previous is actually pointing to the very uh, like very first element of my reverse linked list, because previous has come to the last, which is the very first element of my reverse linked list. Now let's try to get our answer. We'll store our answer in max. We'll simply write it as mat.max. If it's max comma, we need to have two pointer, one that is pointing to head of my node, and the second pointer that is pointing to the first element of my reverse linked list. The first element of my reverse linked list is actually called previous here. So I'll write as this, and this, once we have added it, will move our head node to our next element, and will move our previous to our next element. So this will actually give me as uh, answer, and will return the max. Okay, and now let's, one thing that is remaining is I haven't initialized max. Let me initialize this with 0, and yeah, that's pretty much it. This should hopefully run. Let's try to run it. Okay, where I okay, I haven't written it should return max here. So this will actually give us the answer. And let me try to submit it. Okay, hope you have enjoyed the video. If you have enjoyed this video, don't forget to leave a like. See you on the next one. Bye.